When you're ready.
This is also is going to be fun using this. Good afternoon, ladies and gentlemen. Today I want to talk to you about techniques in computer vision. Okay, we're going to talk about image classification and object detection. I'm going to talk about the image classification and Stefan right here. Hello. We'll talk about object detection. Okay, it's image classification is like you're given about this kind of image and you need to predict what kind of image is this according using the prediction by the machines. And it's measured by the accuracy and measurement of the accuracy of the prediction. For example, like this, you use the training data set of labeled image like cats, dogs, mice, hats, or etc. Okay, the pipeline is here. First, you give the input such as a group of images alongside its label which one is correct. With k with a total of k classes. We call it as training data set. Then learning. And in this step, the machine will learn what kind of similarity of the patterns from all these images according to the classes, its classes, and then evaluate if the image is correct or not according to the original labels. Okay. Next, how? First, we need to read the pattern first. Oh yeah, the previous one is called convolutional neural network, as Fandy already explained for the previous session. And how we read the patterns. First, there's two techniques. The first one is grayscaling. First, you convert the image into grayscale like this. Grayscale like this. Then you read the values of the grayscale values to determine the patterns. And the second one is RGB value. You read the RGB value. This one I present it like hexadecimal. You read the values to determine which one is closer to the other nodes of the color spectrum, and you put them into the array. Okay. Then fit the patterns into your layers. From the patterns that you found, you break it down again into feature A, feature B, feature C, and feature etc. Then you fit them into the layers, into the node, one of the nodes of the layers, of the hidden layers. Then after that you test it. And this is challenge. First a few point variation, then the illumination condition like the lightings. You know, they call it HSL, hue saturation illumination technology. Then the scale variation, deformation, occlusion, like something similar like this, a cat. Like if you from the fence, the cat will show like this. That's the occlusion. Then interclass variation, and then background clutters. Like if your background is to something like disturbing the images like this. And the real application is the image search by Google. In Google, there's a feature called image search. You put the image, and Google will process what kind of image it is. And then from them, they will sort the value, what kind of value about what they detect into the search bar, and then you go to search. And then there will be a facial recognition. Like, do you have any? Is your phone support any kind of the face recognition? Like if you have an iPhone can generate an iPhone. That's basically using this kind of image classification. Okay, the next one will be explained by Stefan. Stefan, come here and explain about this.
Come on, Stefan.
So I'll be explaining about object detection.
Okay, this is
Object detection recognize instead of predefined set of object class by using bounding boxes. So the purpose is to, as you can see in the picture, so it recognize the object between the subject, so that you can recognize it. You can also use photograph or video recorder to see this, and then you can search for the surrounding area with these techniques. So object detection is more complicated due to the fact that an image can have multiple objects in them. And then example of deep learning with object detection is YOLO, the one with Randy said, and also single shot multiple box detector, also called SSD. So the first one you do with this technique is you provide an input, usually an image with one or more objects such as photograph, and then the algorithm will output one or more bounding boxes, and it also uses a class label for its bounding box. So the first one is you only look once, or YOLO. The approach involves a single neural network trained end-to-end that takes a photograph as input and predicts bounding boxes and class label for this bounding box directly. So it consists of coordinates, width and height, also confidence score for each of the bounding box. So this is how it works. The first one, the picture will be divided into the number is not you can input whatever number you want, and then the picture will be divided into that number of grid, and then the algorithm will put bounding boxes for the object that it recognizes, and then it usually put a lot of bounding boxes in there, and then it will calculate the confidence, and so it has the final detection such as this. So the challenge in object detection is, the first one is illuminations. If you have like lighting and from the light or sun, it may disrupt the bounding boxes, and it may cause not so accurate prediction. And then also positioning. An object that is recognized in the front usual way might not be recognized in the vertical or horizontal if horizontally positioned. Rotation also takes a point in this. Mirror image also is harder to detect. There's also occlusion and scale, which is all the challenges that in this object detection. So the real life application is optical character recognition, augmented reality object detection, and pedestrian and traffic detection. So usually the one that we use right now is in autonomous car, which is said to be better using YOLO right now. Thank you very much. Any questions?
Group 1, questions? Group 1, questions? Yes? Ayo, come in. And the group.
Tadi kan Felix asked me something and I asked it back.
Yes.
It's already in the display.
Time is yours. One.
Because I tadi I keluar di ya.
You can ask questions now.
Okay, friendly go. Just yeah, how that it see the pattern, the object. Yay! Go Felix!
Yeah, the thing that I already explained is you only to monitor algorithm first.
Yeah, please explain it again.
Yeah, because I just know I'm not in the class. I feel my butt.
Can you explain it again, please?
God, please.
You can
I'm tired.
He's asking.
He's
No,
asking.
I'm just for the, if you mean the thing. Can you make a slide about the techniques? I already explained about how you detect the pattern.
Yes.
This one, first you need to graphical first. I already tied in TensorFlow, and it's basically you first convert it to grayscale first, then you detect based on the value of how black the object is. It's the basic pattern, but the weakness is if it's more detailed, it will be a bit troublesome for detecting some of for more detailed one. And the second one is the identity value. It's more detailed, but the object detail is more preserved. But the problem is you can actually detect all if the image is like for challenges. Can you move to the challenges? If it's like this, the identity value will be a bit of ineffective.
So based on color.
Yeah, based on color, like the RGB. Since RGB is based from the lightness, but the additive colors.
If the picture is black and white,
Black and white, yeah, just use the tactic one. Simple.
Grayscale.
Grayscale.
Show it. This one.
To classify image, you need a record of what you already have done.
Correct.
But how reliable is it? I mean, to classify a new image, example dog, but different position.
Yeah. Actually, there's another algorithm actually, but I shouldn't explain here because it's already unrelated to this one. It's called general adversarial network to make a randomized based from the images, but it's already off the topic from this one.
It's okay, you can explain it if you
Yeah.
know some.
It's like the image. You got one image, then you give it to general adversarial network to make a fake data to make it like the positioning, like and make the different colors or something, different position. It's basically then use them to then fit the data into the machine to understand to convolutional network.
So are you saying you manipulate the image
Yeah,
to
correct.
make the, the spec of the other one?
Yeah, correct. It's actually true. There's actually a second method, but it's going to take a long time. It's just traditional, take another position, but it's quite tiresome, so forget about that kind of methods.
Next question, please. Group of. Okay.
Very good.
Dafa, ask questions.
Do I have to?
Yes.
Okay. Can we use this? Can we use this technique in cyber security?
Got the topicnya kalau lu ya.
Yeah, but it's still computer vision.
Yeah, it's still computer
Yeah.
vision. So can we use any of these strategy in cyber security department?
Depends actually. If you're talking about the fingerprint, then it may be, but there will be another kind of the algorithm that you probably already know.
We don't know. That's why we ask you. We don't know at all.
That's all the topic anyway.
Maybe from other group
Yeah,
members.
the problem is it's all the topic.
It's okay. This is discussion. You know something you can share.
Actually, it's more like you're reading the text. Actually, you click on the code. It may has the benefit in cybersecurity, but currently I probably don't want to talk further about this. It can, but not the
Do you think
not
it
the
can?
right time.
Yeah, you can
It
explain.
can, but not the right time currently.
Not right, not real time.
Yeah, not the right time for now. We're talking
Or
about
not the
that.
right time.
It's going to be a long talk.
You want another like half an hour to talk about it?
No thanks. I'm tired.
Okay, next question.
My question is the same as you.
Yeah, okay. Group 5?
Ditanya semua.
Just one.
Kok kita group 5?
You're the last one.
okay, we're actually the one that answered Kevin.
Group 5?
Okay, Vin.
Kevin.
One question, please. Can I go to the toilet?
Give me one cases where grayscaling is useful nowadays.
Whoa.
This one, sometimes you only using the RGB is going to be troublesome for this case. You make me to move again to the example like this. This background cutter. Why do I need to do this again? It's like I explained it twice actually.
It's okay.
I already explained it before. It's basically because of the background clutter. If the background clutter occurs, the RGB one it will be rendered useless. So to counter this problem, you're going to need to do it in grayscale. You need the black and white value to make them clear what kind of object it is. At least it will be much clearer than within the RGB.
Okay, any more questions? Yeah. Thank you. Give a round of applause for Group 3. Good job.
Oh.